what are the key trends you are anticipating in next 5 to 10 years in video creation, and what kind of technology advancements you think are needed to cope with it? I know we have AI today, but where does it need to be in next 5 to 10 years to cope with the needs of the users?
Yeah, there's a lot of excitement in AI today. It's definitely moving at a rapid pace. I'm personally in the area of video. I'm very excited by the foundational model enhancements that are going on with technologies like Sora and VO that Google just announced. Right, so it's a rapidly expanding area. It's super exciting to watch the advancements there. Today we use foundational models for text. We use it for audio, for generating AI voiceovers, for example. But tomorrow I also envision us using foundational models to create snippets of video content that can be incorporated. And certain areas like fantasy and high computer graphics usage and these types of things are going to become easier and easier to do with these foundational models that are coming up. So I'm excited for that future where we can add in video foundational models as part of our overall stack and be able to provide an experience which is much more even customized than stock media today, right? So that, I think that's where the biggest disruption is going to be. It's going to be possible for people to dream up a scenario and talk about what if Spider-Man did this, or what if a superhero was capable of doing X, and we'd be able to envision that with AI a lot faster than we can even dream of today, right? So that's I think the most exciting piece of this technology for me.
Vidya, can you more elaborate on how the AI technology is being used to help video creation process? Is it GenAI which is being used? How does it really work, and how does it really help?
There are about 3 or 4 areas in which AI plays a big role in what we do. The first one is understanding the transcripts and the context of the input itself. And for this, we would analyze the text using large language models. And here we are enterprise partners with OpenAI and Anthropic to make this happen. But we also do a number of other language analysis on top of the LLM output in order to correctly identify the context of the conversations, the context of the narration, etc. And then we use computer vision for analyzing the visual component of the video itself, being able to identify who's speaking and at what time and what kinds of objects are present in the video and what is a scene-by-scene analysis of what's going on. And in the third area, we do a lot of analysis on the audio to understand the emotions and the exciting parts of the video that we can extract based on the audio analysis. On the B-rolls, we do a number of things such as identifying when to use B-roll, when to show the speaker, when to show B-roll stock footage, for example, what media to use. Like, if you go and search for a term on Getty, you'd get thousands of results. And how do you pick the best type of stock media B-roll that is suitable for this conversation? Lastly, we have a number of advanced video technologies to determine what is the layout scheduling, the media scheduling aspects of things, and also when to apply sound effects and the visual effects to the videos, the transitions, the animations, and at what levels, and so on and so forth. So these are, I think, a variety of areas in which AI plays a big part in how we create the platform itself.
Can you briefly explain to our audience what is Supercloud? Is it a different name for multi-cloud?
That's a very good question, Faisal. I wouldn't say it's multi-cloud, because multi-cloud is like, if you're, from an enterprise's perspective, if you're consuming or if you're using multiple clouds, you are multi-cloud, or you are into multi-cloud. Supercloud is more like having a common infrastructure across clouds. From our perspective, from the networking perspective, the way I see it is we are able to help customers deploy common networking infrastructure across clouds. So now you know that in each public cloud, networking is done differently. They have different constructs. So from our perspective, we can deploy our infrastructure, common infrastructure across clouds. And from our customers' point of view, they get to have one virtual network or common network across clouds, where if they have to onboard applications or if they have to onboard users, it's one way of doing networking across multiple clouds. So it's a layer on top of multiple clouds. And from our perspective, it's not just public clouds; it's private clouds as well. So you can have one common infrastructure across public, across private clouds as well.
Another term we have commonly heard from Alkira is Extranet-as-a-Service. Can you tell us a little bit about what that use case is, why it's important, and how are you solving for it?
Sure, absolutely. Extranet is nothing new. It's been around for many years. Mainly, what it is as an enterprise, in many cases, you have many partners, and those partners need to have access to some resources within your environment or within your network. So you onboard those partners selectively onto your network and securely as well. And especially this is a very common use case in financials. It's not limited to financials, but common use case in financials where they have like hundreds or thousands of partners across the globe. What they've been doing is bring connectivity from the partners in a secure fashion into their network. They may terminate partner connectivity on some devices in their DMZ where they have the security appliances, all of that stuff sitting, and then they selectively provide access to the resources which the partner needs out of their network. So in many cases, with traditional way of doing this, it takes like a long time for these, especially these financials, to onboard these partners, because many times they have to provision the private connectivity to a partner. Sometimes they have to, send like a CPE device also, which they manage, and then all the selective route leaking and access to the resources. If there are multiple partners with overlapping IP addresses, that becomes an issue. So that takes a long time for them to provision. So all of that takes time. So what we have done is we have allowed our customers to leverage our on-demand networking infrastructure, offer this extranet connectivity to their partners as a service, where it's an on-demand networking platform. So they can bring up this networking platform anywhere across the globe. They can instantly onboard these customers over private connectivity or public connectivity into our platform. We secure it. We take care of all the networking underlying infrastructure, so customers don't have to ship any devices or they don't have to provision this private connectivity, which takes a long time to provision. We provide the infrastructure. We take care of all the overlapping addresses, network address translation, security as well. So the infrastructure is very agile. So they are able to onboard these partners in a very short time. So we have like many customers, especially financials, who are able to onboard multiple partners a week instead of one partner in a month or several months. So the agility is what customers have been looking for from the network perspective, and they can consume this as a service using our platform.
You have worked with thousands of executives on go-to-market and marketing throughout your career. And go-to-market is critical for any product success. So what are the common pitfalls in go-to-market strategy which you would recommend leaders to avoid?
Yeah, I think the biggest thing that underlies really so many of the pitfalls, because there are certainly long lists, but I would say the biggest theme to me is around silos. And I think it can be traced back to the fact that most go-to-market teams, most organizations have grown up in a way where they purchase technology, but it's isolated technology that serves specific teams. They're solutions that maybe the marketing team buys or the sales team buys. And then that coupled with the fact that the teams are organized functionally. There's marketing, there's sales, there's customer success, there's product. And then what all of that does is the siloed tech stacks, the functional teams, it all leads to siloed problem solving and planning. It's really this need to look at go-to-market as a true operating system of the business and not something that one team owns or a particular person is in charge of. This is something that requires real alignment across the company. And when you don't have that alignment, it manifests itself in a variety of ways. So to me, like the biggest opportunity really to solve for companies that want to have best in class go to market, that want to drive growth, it's really all about making sure that go to market is seen as a cross-cutting initiative across the company and breaking down those silos.
Digital marketing has been traditionally a B2C play. In your view, how can enterprises in B2B space benefit from digital marketing?
Yeah, it's an interesting question because at Pavilion, we actually kind of straddle that line. We have a B2B part of our business, and then we also have a B2C part. And we almost have an element of our business that's e-commerce like. And the interesting thing about e-commerce is that those businesses live or die by the performance of their websites and by, their ability to affect outcomes through direct response marketing. And so they are highly performance oriented, highly data driven. They have very experimental cultures that are really agile and move quickly and iterate. And I think in B2B, because we have longer sales cycles, because a lot of things are more sales led and attribution can sometimes be trickier, I think we sometimes lean on that as a crutch, and we are not as data and performance driven as those B2C marketers have to be by necessity. And so I do think over the last 2 years, this is starting to shift though, because with a lot of venture capital starting to dry up or become harder to get at least, I think a lot of companies are shifting their mindset from this growth at all costs mindset to this profitable, efficient growth mindset. And to be profitable and efficient in your growth, you can't just throw money at problems, right? You have to be very granular in how you identify what are the channels that are performing, how can we make small tweaks that will improve our performance. And I think that that's starting to bring B2B marketers a little closer to B2C marketers in terms of the mindset that they bring to the job, and it's forcing them to become more data-driven and performance-oriented.
Recently in Malaysia, in a talk, you have categorized talent development and development of ecosystem as the two foundational pillars of any economic strategy driven by AI. So can you elaborate a little more on why do you believe these are such important pillars for a AI-driven economic strategy?
We're in this phase of AI development that is still early days. It's kind of the Wild West, if you permit me to use that rather Western moniker, right? But we are now in this Wild West phase of very rapid advances in artificial intelligence of all kinds, and LLMs, transformers, GenAI is really just one strand, right? If we want to harness the complete potential of this phase, we have to make sure that as many people as possible participate in how it's being shaped, both in terms of the innovation, in solutions, services, and products, but also in how we govern and how we decide the ethics of it all. So that means we have to educate people, not just the technical and business elite that will design these things, but also the broader public, because the public needs to be friendly to AI, but also constructively critical, right? So we need all these dots to collide to maximize innovation on the product, innovation on governance as well, right? That's number one. That's on talent, right? And clearly, we're seeing talent dearths. Talent in AI is still very expensive, so we got to bring that cost down too. Now, the ecosystem element of this plays into that as well. We need people to transition between different types of innovation actors, right? And startups are really only one sliver of that. Obviously, for scale out and maturity, we need corporate entities to be involved as well. But then we need universities, we need private and public sector labs involved, and again the broader public, and obviously the media as well. And so people need to transition between these different institutions, as they do in successful innovation ecosystems around the world. Silicon Valley is always the shining example, but there are many more examples where people transition from a university into a startup, from a startup into a corporate. From a corporate, they might go back into the university or another startup. And that is not just to maximize the actual experience that people have, but it's also to help us collide dots yet again, right? So again, innovation, true innovation, especially disruptive innovation, is all about colliding dots, right? Colliding ideas to come up with new things. So you need the talent and you need the institutional ecosystem in between.
Right now, we are seeing huge disparity between developed countries and the underdeveloped countries when it comes to AI innovation capabilities and access to the infrastructure. Do you think this big disparity could lead to a global crisis or a labor challenge in any way?
I definitely think it's going to lead to labor challenges. I don't know whether it's going to bubble up into a big crisis, but it could eventually, because as we talk about disparities, right, in technological qualification between industrialized and post-industrialized economies on one side and those that are still developing or that are threshold economies, we're also talking then about the resulting income inequality. And so when that shear becomes broader, then obviously people become very unhappy. And so that could then lead to not just economic crises, but also to political crises. And nobody wants that. And that's also why I'm advising, my friends in Malaysia, in the UAE and elsewhere, to learn as hard and fast as they can from the existing top tier innovators on model creation, primarily in the United States when it comes to GenAI, but China is close behind as a close second. You cannot immediately replicate the kind of compute power and talent that they bring to bear. So learn from them as hard and fast as you can, but then make sure that you develop your own model creation and model application capabilities that are appropriate for your local market. That is because I believe that it's a non-starter for Silicon Valley to run models for the rest of the world that are not culturally appropriate, right? Even though we're very diverse over here. And I think the open source trend that we're seeing now, arguably, spurred by Llama at Meta, will definitely help with that.
Meta is investing quite a bit in building AI data centers and infrastructures. How would these AI-focused data centers be different from traditional data centers?
That's a good question. Today, we are actually using our traditional data centers to build large training clusters for AI. But as we go forward, we're evolving the nature of those data centers. So the next generation will be all facility liquid cooling, for example. So when we look at the way that AI systems are evolving, we went from kind of like a general compute network and storage rack of like 30 kilowatts. We're already seeing rack designs where that thermal density is increasing well over 150 kilowatts, going to over 200, going to over 500. We can even see rack designs where the thermal density, that thermal design point is up at like 700 kilowatts. So the densification of power also is creating a lot of emphasis on liquid cooling as opposed to air cooling, because when you have a building, you can only design for so much airflow to provide that cooling, so many fans, et cetera. So there's the interesting thing about data center engineering is it's a bunch of different disciplines that have to come together for electrical engineering, mechanical engineering, thermal engineering, and even looking at construction methodologies to be able to go faster, and an emphasis on renewables. So there's just pretty much like every aspect of design is now entering into these massive scale data centers.
Multiple big companies have started their own initiatives to build AI accelerators. Meta has announced Meta Training and Inference Accelerator, MTIA, for the same purpose.
Yeah.
Can you share a bit more rationale on what is the need of doing these in-house semiconductor products while we have big companies like NVIDIA, AMD providing the AI GPUs to the industry?
This is a really good question. First of all, we are very lucky to have great suppliers in the merchant market, and the competition is very healthy. I think Meta actually is a beneficiary of that innovation that's coming from merchant market semiconductor companies. The reason why Meta and other companies might want to invest on their own to build AI accelerators is really, I think, kind of coming from two or three places. One, the obvious owner economics, right? There's an economic and financial incentive for us if we can build something that's competitive and we can kind of share some of the costs to build these extremely large training clusters, for example, or just the capacity that's required for AI in general. Having some of that cost be lower just because we're building it ourselves, there's an advantage there. But I don't think that's the principal motivation. At least I can't speak for our peer group in the hyperscaler world. But for us, Vessel, the other aspect of this is finding unique ways to deliver value for the workloads that we understand really well. So at the core, the first generation and the second generation of our training and inference accelerators are really focused on our most critical ads, ranking, and recommendation workloads. That's really central to the company's business. And in many ways, what we've done is, because we are not a cloud service provider, we don't have to serve generic kinds of workloads to third parties. We can actually focus internally on what's most important to us and then optimize those solutions so they run much better, lower power, better results, better performance. And so when you take all that into account, we like to think of that as like a performance per TCO dollar, the total cost of owning a solution benefit for Meta by investing in that way. So I really think this is like a critical opportunity for us to co-design solutions across the software and hardware world that are really targeting the workloads that we care about the most.
A lot of people are now comparing this GenAI surge with the dot-com boom, which happened in early 2000s. The concern is really that will all these AI investments result into material use cases which will justify these investments? So with that context in mind, what are the GenAI use cases you are really excited about for enterprises?
The impact of GenAI is and will be everywhere in the enterprise. And specifically, if I were to drill down into, let's say, the top few use cases, right, the horizontal use cases. So I would say customer experience and support. The amount of time, energy, and cost that we are spending on this today, a lot of this will be taken care of, and it will elevate the customer experience. Use case number 2 I can think of is product or software development and IT. I think GenAI and large language models and products like Lean will have a significant impact on that. Creative content and generating media or sales intelligence. The ones that I spoke about right now are what I call horizontal use cases. Then there are vertical use cases. To summarize, I think that there is the impact we are already seeing, and the road ahead, yes, there might be some trough of disillusionment coming, but the value creation is amazingly incredible. To give you an example, the average handle time at a large contact center has been reduced by 17 seconds. A large team of software engineers, their VP Eng is claiming, and we are demonstrating 40% years of engineering time saved on account of Glean. So yes, there are many examples of where executive leaders at our customers are seeing the value that we are driving. And the value is on cost reduction, value is on revenue generation, value is on customer experience. All of these metrics we are hitting, and we are quantifying it to demonstrate what value a product and a platform like Lean is delivering today.
How is the mobile network operator industry viewing AI revolution? What's in it for them?
I think the opportunity is not just for telco industries, but actually it's for the entire planet. Just purely in the telco space, I saw a recent study from McKinsey. Their estimation is that in next 2 years, the telcos can gain 3 to 4% point EBITDA improvement, and in 5 years, that can get to about 8 to 10%. And 70%, according to McKinsey, the GenAI impact in telcos is seen in the sales and the customer support. I talk to a lot of my telco peers. I talk to a number of enterprises. Everybody's doing something in terms of improving their internal operations with AI and GenAI. For example, in Orange, we have created an internal GenAI platform, which is based on OpenAI. And we have a number of use cases. We have software developers using this platform to develop code. We have people doing document search, create sales proposals. We're doing contract analysis. So there are many, many use cases. Every organization is doing things around that. And that's what I call everyday AI. I believe where there is real opportunity for telcos is in what I call game changing AI. Think about new products and services. Think about how we can empower new experiences for consumer as well as enterprises. So, I give you a couple of examples what we're doing in Orange Business. We are reinventing SMS. We have created a conversational SMS where there is a number, you send a message, you get a response back, so you can start a chat. And we have integrated that with a Gen AI engine so that you can have a much more intelligent exchange. So it's a new chatbot experience powered by SMS. I gave example of SMS. You can think the same for voice. Today, if I call you and you are not available, then I'm dropped off to the voicemail. Tomorrow, someone which is your personal assistant, AI assistant, should be picking up the call and say, Faisal is not around. What do you want to do? I say, I want to have a meeting with him. He told me in the recent email that he's ready to have a call on Friday. And then the assistant say, yes, I check in the email. I can fix a slot. And then the slot is set up. You will have a call, right? So I think that's another example of reinvention of core telco services. The other opportunity that we see for enterprises is many enterprises want to get on this AI wave, but they struggle the very first step with their ability to trust public cloud for very sensitive data. So we saw this opportunity in the market to create what we call trusted Gen AI platform and services. Customers can bring their own large language models, train them in this very sovereign GPU infrastructure. If the customers don't know which model to use, we also partner with French LLM provider called Lighton, and we can offer LLM as a service. Or if the customer says, oh, I just want to have a SaaS application to do document management, then we can also offer that based on using the LLM from our partner and also the infrastructure from us. So we can offer a completely secure, highly compliant, transparent, highly auditable, trusted Gen AI services in terms of helping enterprises to achieve their business outcome. I believe that telco as an industry over the years we've been very much squeezed in terms of our capex and also our P&L. So we have become very much operational efficiency driven. AI give us new direction to be able to think about innovation and think about creating more value for consumer and the enterprises.
What are the key innovations in cellular 6G or Wi-Fi you are really excited about?
Well, I think I'd like to clarify our approach with 6G. So when we think about 6G, we want to position 6G as a platform, and that platform provide iterative development of new services and mostly software-based services so we can create more value for our consumers and enterprises. Secondly, the platform need to be ground up supporting AI. I think we spend a lot of time as an industry to think about how we can use AI for networks, and we optimize, we do capacity management using AI, we do network planning using AI. So there is a lot of AI for networks, but what we don't do is the network for AI, which means that if you have an AI traffic, how the network should treat that. According to Omdia, 70% of the traffic on the network by 2030 will be AI traffic. And if you really think through this, especially the Gen AI traffic versus the traditional AI is very different from a traditional traffic, which is internet based. Internet traffic is very much caching based traffic. The caching concept is very strong. Everybody wants the same content and you cache it closer. In Gen AI, there's no caching because every time the content is generated on real-time basis. In a general web-based traffic, you have a very small request. For example, you want to download a page or download a movie, your download is very high. Whereas in Gen AI is the opposite, because in the prompt that you send a lot of input for high processing. So your request is very heavy. In Google Gemini 1.5 Pro, I guess, you can have 2 million tokens in the request. So I think point I'm making is that the AI traffic is very different. So the second pillar of our strategy is to sort of ground up, build the network which is ready to support future AI. And Edge plays a critical role in that, because you would see more and more the inference need to happen at the edge, whereas the training of those models need to happen in the cloud. And this is a sweet spot for the telco operators to be able to monetize the edge capability, which is something that we were dreaming for a long time.
Can you give us some examples of the network capabilities that can be accessed through APIs? And as a result, what new use cases can be created? What new value can be created?
Sure. So let me unpack this a little bit. So when we look at the total addressable market, basically for network APIs, basically how much developers are prepared to pay for them and what they would like to use in their applications, we see that, by the way, it's around 10 to 20 billion US dollars in 2030. So it's promising to be a very big market. What we see is that there are 3 or 4 main segments of network capabilities, 5G network capabilities, that really stand out. The by far biggest one in terms of value is what we call quality of service, which is the capability that the 5G network has to offer a predetermined service level agreement, an SLA, between the application and the network. That can be a predetermined latency, a bit rate, or a reliability. This corresponds to about 40% of the total addressable market that I mentioned. The second largest segment is identity and security. We know that fraud is a big concern and costs billions of dollars globally. Here, the APIs can leverage the excellent security and authentication mechanism that's built into the 5G networks from start. And the third one, biggest one, is the one of location. Mobile networks knows at any given time exactly where the mobile device is, which makes mobile networks uniquely well positioned for location verification or location retrieval. So together, these 3 areas cover around 75% of the total addressable market, and the remaining part is made up of capabilities to expose information about the device itself, if it's connected, if it's roaming, and information about the network itself. I mean, what is the congestion level, how many users are connected in a certain area, and so on. So clearly, if we could, or when we translate these network capability into easy to use network APIs, they can be incorporated into applications standalone by themselves or in combination with other APIs, and they could serve any imaginable use case. Example, I mean, authentication and location together are very powerful tools for fraud prevention used in banking and retail applications. Quality of service that can be used to provide a predictable performance for a video call, for example, like the one we have now. If we were doing this over video, it would be very useful. Or quality of service can also be used to ensure that the point of sales device, when you pay with your credit card, that transaction is always performed in a very reliable and fast way, regardless of the congestion of the network, if you are at a concert or a hockey game or something like that. And in the end, by putting all these network capabilities at the fingertips, if you would like, of developers and allowing them to understand what to do and combine them in different ways, I think it's only their imagination that will stop what kind of use cases they can come up with.
What are some of the top strategic priorities for ARM in next 2 to 3 years? And what are some of the trends and opportunities you are really excited about?
Yeah, good question. So I think most people who don't know about ARM, we're a compute platform. We've been around for quite a few decades, but I think one of the important things is we're ubiquitous across every platform, every connected device. In fact, I don't think most people realize, but we touch 70% of the world's population. So we're sort of in everything that you touch, but you probably don't even realize, from your smartphone to your smart thermostat to whatever it is at your home. So from a strategic priority perspective, there are things that we're focused on. One is most people think about ARM and they think about the mobile devices. That's sort of the origination and the roots of the company. But we've actually diversified quite a bit outside of mobile devices. We're in automobiles, we're in data centers, we're in everything from an edge connected device. So diversification is now part and parcel of our strategy. It's not just about mobile, but it's about how do we really power the compute platform for all these devices. So that's one. AI everywhere is another big strategic priority for us. So what we believe is, and I'm an AI optimist by nature, but I believe that everything is going to be AI enabled in the future, which is really a great tailwind for us, because you think about things like drug discovery with AI, or tutoring, education accessibility in sort of the remote corners of the world, or AI agents for financial advisors. All of that needs a compute platform, and that's going to be really run on ARM, whether it's in the data center, down at the edge. AI everywhere is really what we believe, and ARM's at the core of that. Third is really about power efficiency. That's a key part of our value proposition, is really being the most power efficient compute platform on the planet.
ARM is seeing growth already in the data center segment. Why do you believe you will continue to see growth in future as well in data centers?
Yeah, so I really look at data centers in two very simplistic segments: general purpose compute and as a companion to an AI accelerator. If you look at general purpose compute, that's sort of ripe for innovation. And we believe that an ARM-based platform, and we partner with many of the hyperscalers and many large companies to really provide ARM-based CPUs that then allow customers to run general purpose compute workloads. That's a simple database or something like that. Now, if you look at the other segment of the market, this is the companion to an AI accelerator. And you look at sort of what you need for a companion to an AI accelerator. It's super important to have a CPU head node in addition to an AI accelerator, because you need sort of the both pairing to do things like memory, to have fast interconnect, to actually run single-threaded processes, software on top of the CPU itself. So you need a good pairing of both the CPU and an AI accelerator. And that's really where ARM fits in, because if you look at the ARM design and our compute platform, it's really focused around flexibility. So we're working with some of the largest companies to provide that flexibility and performance and power efficiency. So a good example of this is Grace Blackwell, NVIDIA's Grace Blackwell, which is well known. And Grace is actually based on ARM for exactly that reason. You're able to have fast interconnect to the memory. You're able to have a flexible compute platform, and you're able to run some of the software specifically on the CPU. And if you think about kind of the macro point, most people think about an AI workload and they think all you need is a GPU, but it's in fact the CPU paired with the GPU that's really powerful in terms of that architecture. If you even look at sort of the hard math is done on the GPU, which is super valuable, but 80% of everything else is really done on the CPU. So you need a flexible compute architecture on the CPU side paired with the companion accelerator to really drive the advancements of what we need in AI.
For our audience who are not aware of what autonomous medical coding is, can you describe what it is and how does it address the specific challenges in the US healthcare space today?
Yeah, autonomous medical coding is basically the process of converting clinical documentation into medical codes meant for the reimbursement processes. And effectively, it's taking the documentation that the providers write. When you visit a provider, doctors do the documentation, and that needs to be converted into medical codes for the insurance claim reimbursement processes. Automating this process, which is basically a core AI problem of converting the document into codes, is basically the autonomous medical coding. And why it's important is because key levers for increasing revenue in healthcare today is accurate and timely reimbursements. And this requires a streamlined RCM process. Medical coding and claim submission is arguably the most critical process in this, impacting both mid-cycle and end cycle of the RCM process. And the more providers can get accurate reimbursement and timely reimbursement, they can function much, much better. So we have built an incredibly powerful autonomous coding solution to automate high volume claims. And talking about how we have built this, two key aspects of our architecture is clinical GenAI architecture, which is basically the agentic GenAI architecture, where we have taken the whole approach of breaking down the complex problem of medical coding into small individual coding aspects. And the second key aspect of our solution is the clinical knowledge graph that we have built in a very extensive way. When we combine these two, we get a very, very powerful combination of explainability and extensibility of our platform. And we have taken a very, very unique approach of delivering all of this automation inside the EHR, right? Inside Epic, inside Athena, or inside Cerner, making sure that there is no workflow change, absolutely zero workflow change for the provider organizations.
We have made a major leap forward in communications innovations. However, I'm assuming story still continues, and there are more problems, more gaps to be addressed in this space. Can you share some examples which people like young professionals, students can work on to help you out?
Yeah, so some of the innovation areas for us, they come back a lot to generating better products in a smaller and smaller form factor, better power efficiency, better packaging techniques so you can handle the thermal effects. So we have a variety of customers all the way from space applications, military type space, to commercial space, to industrial applications. And what we're finding is, the term that's used a lot is SWAP, size, weight, and power, and the military guys use that term a fair bit. And even on the commercial side, you hear the same sort of concept. So I think there's a large trend and desire to continue going down the curve of lower weight, smaller packages, better integration in that respect, and preserving performance or enhancing performance. So there's a lot of areas to innovate in there. We're packing a lot of power into little devices like O202, very, very small devices now. We can definitely use help in terms of packaging capabilities, new topologies for circuits, new architectures for circuits. We're moving more into the GaN side of the semiconductor industry. And GaN is still pretty young. It's a higher efficiency way to deliver power amplifiers and power systems, but it's still got a long way to go. I think there's a ton of innovation that's required to make GaN more of a mainstream, to drive the cost down. One of the big problems with GaN is the gallium nitride, is the cost is too high. And so that's a big area that we need to focus on. Packaging those types of products, that's a big challenging area too. So there's a lot of places to innovate in our area, in our industry.
Indeed, there is a lot of excitement about AI, but can you categorize what's underhyped and what's overhyped in the current AI era?
So one thing that's overhyped is, people are saying that every piece of software is going to be rewritten in the near future. That's not happening, right? Because, if you think about enterprise software, Salesforce, Workday of the world, it's going to take time for them to, you are talking about a 5-year or 10-year cycle when you have such a paradigm shift, have an architectural shift. A year and a half ago, almost 2 years ago, when ChatGPT was released, that people thought, including myself, again, that, wow, this enterprise stack is going to be totally distributed in the next 2 or 3 years. I think all of us should be disappointed, and it's overhyped. It's going to take longer time. The underhyped thing is just the fundamental implications to everyone, for people in the enterprise, and then for 500 million users we Gen serve. I don't think people even understand the potential we can make their life better. Me as a consumer, how am I doing financial stuff? I actually was talking to a friend the other day. Hey, why can't bots do it for me to do so much work, right? It's just I believe that 5 or 10 years from now, the bots or the generative AI is going to do a lot of the automation for me. So my life is going to be, deal with a lot less the logistics stuff. And then there are many more. So the way we work, the way we live is going to be very different.
You have lived through the evolution of Wi-Fi technology from its inception to where we are today. You must have noticed that in last 2.5 decades, primary focus of Wi-Fi evolution has been on data rate improvements. And obviously that resulted into better user experiences and new use cases. But what about the future? Is data rate evolution mindset still going to be the primary thing, or there are other aspects we need to prioritize, and why?
No, it's a good question, but I do want to sort of clarify that I think the industry has moved away from the notion of data rate, I would say for a little over a decade already now, right? And the way I look at it from a Wi-Fi perspective is the speed, which is data rate, that was the first vector to go conquer. And the first generations of Wi-Fi, A, B, G, N, that was their focus. Going into the 2010s, things have changed. And you have to look at it from the perspective of what are the use cases somebody is trying to go solve for. Back in 2008, 2009, the focus was on mobile internet. So in order to get you to mobile internet, you needed speeds and feeds, and you needed that for mobile devices as well. So the focus was on making sure that you have better data rate across mobile devices in your homes. Now, when you transition to the 2010s, I think we went from just having phones for internet to wanting to watch videos wherever we are, mobile videos. What that requires is not just data rates and speeds, but you also, to some extent, need coverage. You need to make sure that that data rate goes across to different devices which are sitting at different places in a building, whether it's a home or an office. So, when you looked at 802.11ac, which is back in 2012, I think the focus moved to coverage. So that's where, beamforming as a technology was introduced and productized. So there was a shift going from data rate to coverage. Now, when you proceed further into the 2010s, say talk about 2018, 2019, you as a consumer, you not only consume those videos, but you were creating videos. And you were not just creating videos as in video content, but you're actively using, think WhatsApp, for example. You're actively using video to actually, and push data out into the cloud. So you were creating video as well, creating content as well. So that required a step back, and you look at Wi-Fi technology and see what is the right way to approach it. So Wi-Fi 6, which happened in 2019 timeframe, those are nuts and bolts redesign of Wi-Fi that focused on, not just speeds, not just coverage, but on network capacity. Now, how do you make sure that more of these devices are actively using the channel and they're able to interconnect and proceed? Now, as you enter 2020s, 2022, 2023, now there is a larger emphasis on latency and network capacity. Again, think the AR and VR glasses that Meta's producing. Now, you really need those devices to have extremely low latency and very high reliability communication. So, now we've moved from speeds to coverage to now focusing on capacity and latency. And that's what Wi-Fi 7 strives to do. And, it's my firm conviction that that's what the future generations of Wi-Fi will also focus on, Wi-Fi 8 for that matter.
How would you explain the value proposition of Wi-Fi 7 to a common everyday user? Why should they upgrade their device because their device has Wi-Fi 6 but not Wi-Fi 7?
Well, that's a great question. And, that's partly what I do is I have to step back every single time and think about how I sell Wi-Fi to my mom. One of the things we did about 5-6 years ago is to say, I can't go convince my mom that she needs to go buy 11AX router or 11AC router. That doesn't make sense. So we said, okay, let's step back and rename Wi-Fi. Let's go with this generational nomenclature. We pushed the industry to go adopt a generational nomenclature. So I can go to my mom and say, Mom, go get 7. 7 is better than 6, and then 6 is better than 5. Now, jokes apart, what does 7 bring, right? First up, having that conversation with the consumer that, a next generation of Wi-Fi is available. It's that much easier when there is a generational nomenclature. Okay, that's 7 now. So you're able to say, hey, what are you going to do with 7? Faisal, you're a technical person. The case in point here is that with Wi-Fi 7, 6 gigahertz also becomes pretty much mainstream. 6E introduced 6 gigahertz. A lot of devices had 6 gigahertz, but with Wi-Fi 7, 6 gigahertz becomes mainstream. What that means is you have really clean channel that you can use to make sure that you have that low latency communication, you have that high reliability, high capacity communication. So that's what I would focus on when I go convince my mom. I said, hey, you want that bufferless video. If you want your grandchildren that come to your home, work on their gaming devices, or if you want your son wears these AR glasses, if he needs to have a good experience, that's where Wi-Fi 7 comes in.